This is the story of Sudan Airlines Flight 109. On the 10th of June 2008, an Airbus A310 was flying from Damascus to Khartoum International Airport. Now, the Airbus A310 that was making this trip was not in perfect flying condition. The left-hand thrust reverser was out of commission. Now, for those of you that don't know, thrust reversers are used to slow the plane down during the landing sequence by directing some of the high-pressure air to the front of the plane. Now, these sound important, but they're really not. Reversers are more nice-to-haves than must-haves. You can totally operate a plane with just one thrust reverser disabled. It just means that you have to do a wee bit of additional work when you're landing your plane. On the ground in Damascus, the pilot of the A310 was busy making calls to Khartoum to get a feel for the weather at Khartoum. By the time the plane got close to Khartoum, the captain would get his answer. The weather at Khartoum was bad, to the point where the plane had to be diverted to Port Sudan International Airport for a bit. The A310 waited at Port Sudan International Airport for about an hour and 15 minutes, waiting for the weather at Khartoum to clear up. Then they got the call. The weather was much better for a landing, and the pilots took the A310 back into the skies, this time with the intention of putting the plane firmly on the ground at Khartoum. The pilots would be making a nighttime approach to runway 36, and the controller gave the crew the wind conditions for the runway. The wind was coming in from 320 degrees at 7 knots, and the runway was wet. Sure, these were not the best conditions, but it certainly was not the worst. So the pilots saw no reason to worry. The pilots flying the Airbus A310 with 214 people on board with the runway at Khartoum and then started to take the plane down. As the plane got lower and lower, the lights of Khartoum went flying by. Runway 36 now shone brightly in front of the pilots. Their ordeal was almost over. The captain and the first officer were in sync, and they were working as a team. At 5:26 p.m. UTC, the Airbus touched down 900 meters or 3,000 feet from the threshold of the runway. The captain immediately put the engines into reverse in an attempt to slow the plane down. But to his horror, he was having a hard time keeping the massive plane on the centerline of the runway. He glanced down at his instruments to see how fast his plane was bleeding off airspeed. It was not fast enough. He knew that at the rate things were going, he would not be able to stop the passenger jet before the runway ran out. And unfortunately, he was right. Flight 109 overran the end of runway 36, but the jet had so much momentum that it just kept going and going and going. It went on for another 215 meters or 705 feet after the runway ran out, and it came to a stop. But this ordeal was far from over. A small fuel leak had started at the wing root on the right-hand side. This leaking fuel came into contact with the hot engine, starting a fire on the right-hand side of the plane. The fire quickly spread, and it meant that the 3 exits on the right-hand side of the plane could not be used due to the fire. In the ensuing chaos of the evacuation, 30 of the 214 passengers did not make it off of the plane. This was a simple landing that had gone horribly bad. As dawn broke, the jet was just a charred pile of ash at the end of runway 36, with the wings being the only part that was kind of intact. So, how did this happen? Even though the plane was charred and mostly ash, individual parts of the plane survived, and importantly, the flight data recorders and the cockpit voice recorders were okay. One of the questions that they immediately had after the crash was this caused by a brake failure? And the flight data recorder would help them answer that question. The FDR detected that there were no brake failures on board the plane as it landed. This was backed up by a physical examination of the brakes themselves. The FDR recorded no hydraulic failures as well. The biggest proof of all was right there on the runway. Skid marks along the runway indicated that the pilots tried their best to stop the plane. The brakes were engaged so hard that the wheels locked up. The skid mark also disproved another theory. The runway was wet, and so hydroplaning was a real issue. This has caused problems before. Atlantic Airways Flight 670 was a BAE 146 that was landing at an airport in Norway, and it hydroplaned, causing the plane to fall into a gorge at the end of the runway. Let me know down in the comments below if you want to see a video about that crash, by the way. The point is, hydroplaning was an issue, but it leaves behind a telltale skid mark and mushed rubber. But the investigators were not seeing that here. They then decided to go through the flight data to see what more could tell them. This is where they noticed something out of the ordinary. The flight data recorder recorded an indicated airspeed of 140 knots and a ground speed of 155 knots. Now, let's quickly get some terminology out of the way. Indicated airspeed is the speed that you read off of your airspeed indicator, and ground speed, as the name rightly hints at, is the speed at which your plane is moving relative to the ground. In this case, the difference between the ground speed and the indicated airspeed is about 15 knots. Where did that extra 15 knots come from, you ask? Well, the plane had a tailwind component that the pilots failed to notice. This meant that the tailwind was pushing the plane along, giving it more speed than the pilots thought it had. In simple terms, due to the tailwind, the plane was 15 knots faster than the pilots expected it to be. This then combined with the next factor to make the pilots' lives even more difficult: a smooth touchdown. Wait, what? I can hear you asking. I thought smooth touchdowns were good. Well, in fair weather and if you have a lot of runway, buttering a landing is very good and very, very satisfying. But in cases like these, the best thing to do is to plant your plane onto the runway firmly and to then brake hard. The smooth landing partly explained why the plane touched down so far down the runway. Then, once the plane was on the runway, the captain selected the reverse thrusters. Remember how I told you that the left-hand reverse thruster was disabled on this plane? Well, that bit of information is about to be very important right now. The captain selected both engines to reverse, but since the left-hand reverser is broken, it did not engage, and only the right-hand one did. This meant that the plane lurched to the right as only the right-hand reverser kicked in. This was countered by the pilots pushing down the left pedal, which put the plane back on the centerline. But here's the thing. To get rid of the imbalance, he disabled the reverse thrusters. Now, let's take stock of the situation of Flight 109. They came in too fast due to a tailwind component that the pilots forgot to account for. They landed too smoothly, causing them to eat up precious runway. They then botched the one reverser disabled procedure, meaning that the plane now had no reversers and would take even longer to stop. The captain did engage the reverse thrust again, but when he did that, the plane only had 80 meters or 260 feet of runway left. That was too little too late. But there was one thing that could have helped the pilots: the auto brake system. The auto brake system is exactly what it sounds like. The plane automatically brakes. You can set it to multiple settings depending on how aggressive you wanted the braking to be. But in the case of Flight 109, the auto brake was not used. The first officer asked the captain if he wanted to use it, but he opted to not use it. Would that have made a difference? Well, Airbus and the BEA did some simulations to figure out just that. They had a simulation where they did exactly what the pilots of Flight 109 did, and to no one's surprise, the simulation ended in a runway overrun. They then tried out other scenarios to see if the pilots could have done anything to get the plane to stop in time. The next scenario called for max braking after the plane had been on the runway for 2,000 meters or 6,500 feet, along with full reverser on the right-hand side. Even this scenario ended in a runway overrun, but it would have been much less violent as the overrun would have happened at 48 knots as opposed to the 76 knots that had actually happened. So, to make a small educated guess, I think it is safe to say that the severity of this accident would have been greatly reduced had the auto brake system been in use, as the plane would have started to brake a lot sooner than it did. Something that may have made this accident deadlier than it needed to be is something you don't think a lot about: hand luggage. The report says, and I quote, "Hand luggage delayed the evacuation process," end quote. Now, I don't know if this was because people were trying to get their bags as they tried to exit the burning plane, or if the bags in the overhead bins had fallen into the aisle during the accident, thus impeding free movement of people inside the cabin. It is certainly interesting, as you don't see hand luggage being cited as a reason for a slow evacuation often. This accident is very similar to the TAM 3054 crash. In both cases, the planes had one thrust reverser disabled, and in both cases the pilots knew about the disabled reversers, but not following procedure ended both flights in the same way: in disaster. If you want to watch that video, I'll have a link to that video on your screen right now. Thank you for watching this episode of Mini Air Crash Investigation. If you like the videos that I make, do consider liking and subscribing. It will really help the channel grow. I will catch you guys next time. Stay safe.